Okay, so today's lesson we're going to look at parallel and perpendicular lines. So if you think of parallel lines are when they run the same way, yeah? Or they run like that. So what do you think? Do you know anything? Yep. Yeah, they have the same gradient, so their m is equal to each other, yeah? If we have perpendicular lines, what perpendicular means is that you'll have one line and then you have another line going straight through, which creates a 90 degrees angle. That's what perpendicular means, yeah? Two lines cross, so they might cross, and they create that 90 degree angle, okay? So we've got a couple of rules that we know, and now you've already said for the parallel one that you said if two lines are parallel, their gradients are the same. So can you see here, even though this one is 2x plus 3, it crosses at 3 on the y-axis. This one crosses down at -4, but it's parallel because its gradient is the same there, yeah? So there's that. So if you're given that information that this line is parallel to that line, then you must know its gradient. Okay, the other one, the perpendicular, we're going to get the rule here, and it's this rule here that we're looking at. Okay, so, and what that means is if they're perpendicular, if you take their gradients and you multiply them together, the answer will, or if they're perpendicular, will be -1. So that means if I know, say I know one of the gradients, and if I know that it's -1, does that mean I cannot solve and find the other one? Yeah, if they tell me they're perpendicular and I have been given one of them, I must be able to work it out. So let's go have a look at some of these questions. So example 1, there, the equation of a straight line passes through a point 1 and 2. So I like to always start writing that because it's going to help me think. I obviously might need to use that point. And is parallel. So when I know it's parallel, so you should be writing these things above it. Write same gradient. And then you'll start to remember what you've got to do. So it's parallel with this equation here. So is that in gradient intercept form there? That line? No. So you got to rearrange it to be like this so that we can read off the gradient, yeah? So let's rearrange this one. I'd have -y equals -2x plus 4. I didn't move that 4, did I? Now we don't want the negative there. So when you have a negative on there, it's like I can divide all of that by -1, can't I? Yeah? And that's like saying -2x over -1 plus 4 over -1. So what would that simplify to? A negative? 2x. Good. Because a negative divided by a negative gives a positive, but this one will be -4. Good. So what's the gradient there? 2. Yeah, we can see that the gradient's 2. So we know the gradient for our line is 2. Oh, I'm not going to do what they're doing, yeah? So I now know my equation so far is this, plus c, yeah? But what do I do to find c? What can I use? I can use this one, can't I? Yeah? Because we said that's an x and that's a y. Yeah? And I put in, every time I see y, I put 2. And every time I see x, I put 1. So therefore, what is c? So I've got 2 equals 2 plus c. Yeah, good. If I move that over, it'd be 2 minus 2, wouldn't it? So my equation for this line is y equals 2x. All right? Okay, so then in question B, it says find the equation of the line. It still has that point up there, 1 and 2, because this is part B, yeah, so I can still use that point originally, but is now perpendicular to this line. Now, when we rearranged that, we found the gradient was 2, didn't we? Yeah? From before? Do you remember? Yes? Oh my God, sorry. I meant to highlight it. We know that it's 2. So if it's perpendicular, knowing the rule, m1 times m2 equals negative 1. So I'm going to know, I know that line is 2. So this is going to be my perpendicular gradient, is negative 1. So if I move that timesing 2 over the other side, what will it do? Divide. So can you see my gradient of my perpendicular line is negative 1/2? Yeah? You're happy with that? I use that rule. So now it's still a straight line, so it follows this pattern, and I know that m is negative 1/2. And how do I find c? Like what I did before. Yeah, and I'm going to substitute 1 and 2 into it. So 2 equals negative 1 on 2 times 1 plus c. So it'll be 2 plus 1/2 equals c. I don't want a mixed number. I want a fraction. So what would that be? What's 2? Yeah, good. 5 over 2 equals c. So, the equation of the perpendicular line is plus 5 on 2. Yes? Now, what I want to just quickly show you, you could write this as another way. Sometimes they don't have it written with fractions. And the way they get rid of that, and so you might need to see the equation not as a fraction. Now, see how they're both over 2? Yeah? To get rid of that fraction, if I times that by 2, that would get rid of it, wouldn't it? Yeah? And if I times that by 2, that would get it. So if you're going to times it by something, you have to times everything by that. Otherwise, you're changing the weight of the equation, aren't you? You're changing the actual values. But if I times everything by the same thing, it would be the same. Wouldn't that be true? Yeah. If I added up all our weights, and it got a number, say, if I times it, we're still going to get the same, like we're still in comparison. So anyway, so if you times it by 2, that's the same thing, as long as you do it to everything. And then I get rid of the fraction, so it might be written like this. So what would that become? That's 2y, but this one becomes just minus x, yeah? Because don't the 2's cancel out? And what would that last one become? 5, yeah? So sometimes there may be a version of that in your multi-choice. Or if the question asks you to write it not in fractions, yeah? They might say, the values, find the values, they have to be greater than 1. So that means we just got to get rid of the fraction at the end, all right? So find the equation of the perpendicular bisector. So a bisector, if you cut something as a bisector, that means you're cutting it If you're cutting something exactly in half, a bisector, that means these are this length is equal to that length. Yeah? They're the same. All right? So if you're cutting something in half, what does that make that point? What do we call that? Good. Excellent. Someone said it. That's a midpoint, isn't it? It's a exactly halfway between two values. So that's a midpoint. So find the equation of the perpendicular bisector to this line here between the points 0 and 2. So what it does help to know is maybe draw an example of it. You don't have to go crazy, but if I write that, I'm just saying that's -1, -6. Then I've got a straight line, and I'm saying that one's the other point, 2 and 0. Yeah, I'm just making it up. So I know the question's asking me to find this equation. Yeah, this is the question. Find that equation. So if I find it, I know that they've told me it's a bisector. So I know the gradient. I could work out the gradient. So, and also, I need to find C. So I need a point, don't I, to find C? And I'm going to use that midpoint and find that and use it to find the line. Yeah? So let's go. So first I might get the gradient. So we know the gradient times the other one will give -1. So I need to get this one's gradient. So let's rearrange. What is it? It's the same, is it? So -y equals -2x plus 4. So, yep, is 2x plus 4. So the gradient's 2. So I'm saying 2 times... So what does the perpendiculars one equal? Negative a half? Yeah?
This is 2x negative 4 plus.
Oh yeah, sorry. Yep, sorry, you're telling me that's negative 4? Good. Alright, so at the moment I'm trying to find this equation, and I know that it's negative a half x plus c. So now I need a point. So I'm going to find the midpoint. Need a point, so find midpoint. Yeah? So off we go. Remember, x at the midpoint, what's that going to be? It's x1 plus x2 over 2. Yeah? And y at the midpoint is y1 plus y2 over 2. So I'm going to call this x1, y1, x2, y2. Yes? All happy with this? So I've got negative 1 plus 2 over 2. What will that be? A half?
Yeah.
And I've got negative 6 plus 0 over 2. So it's negative 3. Yeah? So I have this point to put up into this to find C. Yes? So I'm going to go over and I'm going to write this out again. And I'm going to use my midpoint. So I'm going to use, was it negative a half? Just a half. Oh, it's negative a half, isn't it? Yes? No, positive. It is positive half. And negative 3 into there. So I've got negative 3 equals negative a half times a half plus C. So that equals what? Negative quarter. Yes? And what's negative 3 plus a quarter? You need to leave it in fractions. So, if you change negative 3 to quarters, wouldn't that be negative 12 over 4? Yes? Plus 4. So what's that? Negative 11. So I've got the equation now to be negative 1/2 x minus 11 over 4. Just to be annoying, because you know they will be in the exams, what about if I want to say no fractions? What about if I times this one by 4, that'll get rid of that fraction, but I've got to do it all the same, but it'll also help here, won't it? Yeah, because doesn't 4 and 2 cancel down? Yeah. And this one times 4, so I'm left with 4y equals negative 4 over 2x minus 11, yeah? And what's negative 4 over 2x? Yeah, negative 2x minus 11. So you could have a rearranged version of those numbers, okay? So that's what happens. Those questions get a little bit harder and you see those things and you go, my answer didn't look like that. That's what they're doing, yeah? And be careful if they ask for a number that's not a fraction. You've got to do that. Okay. All right. If you're cutting it exactly in half, if you've got a... Oh, did I go the wrong... Let's do this example. So 2 lines, 2x minus 5y equals negative 2, and 3x minus ky and m are perpendicular. So if they're perpendicular, just start thinking about it. Go, all right, it's that, yeah? Negative 1. And they intersect, and that's good. We need to know a point. So what's happening? You've got 2 lines, yeah, perpendicular, and they cross at negative 1 and 0. If they cross at negative 1 and 0, that means that point is in both the equations, isn't it? It's on both lines, so you could use it, yeah, because they're on both lines. So, what's our question asked? So they want find the values of k and m. So we'll just do the same. So let's find, I'll call this equation 1. And there's equation 2. Now they're being nasty, you know why? Because they're using the letter m and we like to use it for gradient. But in this term, it's got nothing to do with the gradient. Can you see that? They've just used m and that's just being nasty. But anyway, so let's rearrange equation 1 to be in y equals this form so I can read off the gradient. So I've got 2x minus 5y equals -2. So I'm rearranging. And what am I going to do? I'm going to divide by -5, aren't I? So really, what's the gradient 1 for us? Is 2 over 5. Are you happy for that? What I've done is taken that one. There, yeah? That's the gradient?
Yeah.
Yes? For this rule here, that part. And now I'm going to do it again for equation 2. And it's going to be 3x minus ky equals m. So remember, the number in front of x is always the gradient, yeah? So I've got -ky equals -3x plus m. So y will be -3x divided by -k, or m divided by -k. So what's the gradient for this one? It's this number, which is? Yeah, but that'll become positive, won't it? 3 over k, yes? So that's m2. All right, so we've got that one up here now. So if I go and draw that over there, so I've got m1 times m2 must be -1 because they're perpendicular. I'm going to pop them in. So 2 over 5 times 3 over k. Now, surprise, surprise, I only have one letter unknown. So I can find k, can't I? Yes? So when you times fractions, you times across the top. And I want to get the k up the top, don't I? And by itself. So if I move it over the other side, that will become -5k. And because I'm trying to get k by itself, move that 5. And I've found k. Yes? Now, where's m? M's up here, isn't it? And if I know k, and I also know a point, don't I? Yeah? I might use these two now and find it. I'll use a different colour, help you. So I'll have to do this one. I actually know that this is 3x minus 6 over -5 times y equals m. All right, let's tidy that up. That would become 3x plus, wouldn't it? Because there's negative. Yes? Okay, and I'm going to use this point. So every time I see x, I'm going to put on -1. So I've got 3 times -1 plus, and what would 6 over 5 times 0 equal?
0.
Wouldn't it be 0? So what does m equal? You got it. We've got our two answers. Yes? H, that's why.